Okay, today we're going to solve polynomial equations. And usually when they use the word polynomial to describe something, it usually just means that there's no restriction anymore to what power or what degree that equation is going to be. We've solved squared equations using factoring, quadratic formula, completing the square, but we haven't really done much beyond the second power. And so we're going to see equations today. We're actually going to find answers. We're actually going to, solve for x, but the powers are going to be third power, fourth power, fifth power, etc. And so these problems are set up. They're pretty nice to where they factor in different ways. And so I'll just give you, I think I have 5 or 6 examples that pretty much cover all the weird things you're going to see in the homework. Now you're sitting here, we're looking at this one here. This is more of a warm-up problem. This one's already ready to go. Remember, whenever you have a bunch of stuff being multiplied together and it's all equal to 0, then individually these pieces must equal 0. For something times something times something to equal 0, then one of these hunks of stuff has to be 0. So we separated into 3 pieces in this case to give the 3 different ways that this thing could be 0, which would be x plus 2 must equal 0, x minus 2 equals 0, or x squared minus 8 equals 0. This one leads to an answer of x equals negative 2. So there's one answer to this problem. X equals 2 is the other answer. And then x squared equals 8 by adding 8 to the other side. And then why don't we just square root both sides of this equation? We can just go square root, and we have x equals plus or minus the square root of 8, which is a pretty good answer, but remember, when we're always supposed to, with square roots, we're supposed to, if there's any pairs inside there, we have to get them out. This is plus or minus 2 times 2 times 2. That's what makes 8. And a pair of 2's will escape out of here as a 2, and then that other 2 will be stuck inside. So the square root of 8 is the same as 2 root 2. Those are the same thing. You can even get your calculator out right now and find the decimal for that, and then take the square root of 2 decimal times 2. It'll be the same as the square root of 8. All right, before we move on though, let's just kind of make sure we understand what's happening here. This is really a fourth power equation disguised. There's a first power, and then 2 more, squared power. That's 1, 2, 3, fourth power. And we have 1, 2, 3, 4 answer. This is 2 answers right here, plus the other 2 there. We have 4 different answers. Speaking of that, let's make sure we understand what's happening today. We are solving equations. In other words, we are just finding the answers. Yesterday's lesson, we were factoring, so we were just rewriting stuff in a different way. This is a little more straightforward as far as you know what you got to get. You have to get what x equals, and we found these 4 for this one. But keep in mind, this problem was factored already. It's already written as something times something times something. So let's move on to something that is a little trickier. So here's an equation again. We're solving equations. They're going to have equal signs in them. They're, I think, pretty much always going to be set equal to 0. And we have to find a way to factor this. Because if we can factor this into 2 separate pieces, then we can break them up, set them equal to 0, and solve. This has 3 terms. 1, 2, 3. We've seen this a few times. We saw it in the homework yesterday. We need to recognize that this is nothing more than just a typical factoring problem like this, factoring a trinomial. But the powers are higher. Instead of x squared and x, it's x to the 4th and x squared. So when it's x to the 4th right here, that means we need to have x squared and x squared here, because x squared times x squared equals x to the 4th. 63, we need 2 numbers to multiply here to make 63. First thing that should come to your mind is 9 and 7. And 9 and 7 are 2 away from each other, so it's all going to work out. So we're going to go ahead and put a 9 and a 7. Doesn't matter which spot, just put them in either spot. And we can see that that does equal 63 right there. But we need positive 2 when we do, this is 7x squared and this is 9x squared. We need positive 9 and negative 7 so that we have negative 7x squared plus 9x squared equals positive 2x squared. And of course we have positive 9 times negative 7 equals negative 63. Now, we have factored this thing. That means that these two individual pieces that are multiplied equals 0. Therefore, x squared plus 9 equals 0. X squared minus 7 equals 0. How do you know you're done with these? You have to find x. You have to solve for x. So we are clearly not done. We're now going to go x squared equals negative 9. And then we're going to take the square root of both sides. But notice this time we have the square root of a negative number. Oh well, it is what it is. It's going to be x equals plus or minus 3i. And we've already done all this kind of stuff. I'm just, when we have a negative inside of a square root, it comes out of the square root as I, which is right there. And then all you have left is the square root of 9, which is 3. And since we took the square root of both sides, it's plus or minus. We always have to plus or minus. So there's 2 of our answers right there. They're imaginary answers. They don't really make a whole lot of sense, but they are answers. Over on the other side, we have x squared equals 7. We have x equals plus or minus square root 7. I'm square rooting both sides here, and that gives me plus or minus square root of 7. Those are my other 2 answers. Notice that was not a negative in there, and the square root of 7 is not a perfect square, so we're just leaving everything the way it is for that. This was a 4th power equation. Look up at the top there, x to the 4th was the degree, the highest power is 4, and we have 1, 2, 3, 4 answers. None of them are pretty, but hey, they're answers. All right, next one. This is going to be a pretty new concept for you. You might have to really go back to Algebra 1, 2 to remember how this works. But this definitely looks different. You have a 3rd power. You have 1, 2, 3, 4 terms. That is a totally different problem than the last one we did. When you have 4 terms, well, let's not forget what we're trying to do here. We have to factor this whole thing, so that it's written as some sort of multiplication equal to 0, so then we can break it up into pieces and solve the more simple equations. But how? That's the question. How are we going to factor this? So the trick is, whenever you have 1, 2, 3, 4 terms, we want to think of this as 2 things and a separate 2 things. And this is called factor by grouping. We're going to look at this little group right here, and then we're going to look at this little group right here. We're going to factor them individually. We're going to individually factor out the GCFs of the 2 sets of 2. So for the first set right here, what's common to both of those is x squared. There's at least x squared in both of them. So we're going to write x squared parenthesis x minus 2. If you look at that right there, if I were to distribute again, I'm not, but if I was, just to check it here, it's x cubed right here, which is that, and then minus 2x squared, which is that. So I'm looking at these 2 things, even though I know there's other stuff over here too, we'll get to that, but I'm just focusing on these 2. It's called factor by grouping. I'm grouping these 2 together, GCF. Now I'm going to look at these 2 and GCF. GCF over here, we're going to put a plus because that's what the sign is, and then 3. The GCF of 3x minus 6 is 3, and we're left with x minus 2. Right? Look, 3x, and then minus 6 right here. Right now, if I gave you this problem and I said, go ahead and distribute all this stuff back out, it would be this. So I haven't done anything wrong. I'm just rewriting it. It looks different, but it's still equal to the original. So what's the point? Why am I doing this? Because these problems are rigged up. Notice, I'm going to give a different color here. Notice that there's an x minus 2 in both of these. The problems are set up so that if you do it right, there's going to be the same factor twice in each of these. And so now we're going to do another GCF. This is a little weird for some people to understand. So you have to, I'll go a little slow, pay attention to what's happening here. Let me use another color. Think of it like this. I have this thing here, and I have this thing here. And each of them has a common thing in it now, the x minus 2. So I'm going to factor out the GCF of this green underline and this other green underline. The common factor of both of those is the x minus 2. So that's going to come out front now as the GCF. And then I'm left with, if I take this away from those, I'm left with x squared plus 3. Equals 0. Let me explain this again. Think of it like this. This is my GCF. Kind of like, let's go a real simple one. What if I had, this is a made-up problem over here. What if I had 2 times x plus 1? If I just had something like that. Let's say the original problem was 2x plus 2. And then I factored out the 2 here. And I wrote x plus 1. Well, if I distribute this, that's 2x plus 2. So when I look at this, I saw that there was a 2 in both, and I put the 2 out front, and I rewrote whatever was left. There's an x still left here, and over here, since the 2's gone, it's just a 1 there now. 2x plus 2. All right, back to this. This is where it gets a little weird. You have to realize I did the same thing here. I have an x minus 2 in both, so I put it out front. And notice how if I take this thing and I distributed it to the x squared, I would have this. I'd have x squared times x minus 2 distribute, right? That times that equals that. And notice that this times this equals this. 3 times x minus 2. So the x minus 2 is still getting, it could be distributed into these two things to create this. I'm just doing it backwards. I'm pulling out the x minus 2, putting it out front, and then I'm writing this plus this here so that this would distribute. Stare at that. If you need to pause it because you need to understand what just happened there. And by the way, it's factored now. Now we have something times something equals 0. So we can break it up. X minus 2 equals 0. X squared plus 3 equals 0. So x equals 2. X squared equals negative 3. X equals, I'm going to square root right now, plus or minus square root negative 3. But that means plus or minus I root 3. There's 2 answers right there. There's another answer right there. 1 answer, 2, 3, third power was the highest power. So we have 3 answers. Here's a pretty quick one, but only if you see what to do. Step 1 always is look for a GCF here. Notice there's an x that's common to both of those. So we have x, parenthesis, x to the 4th minus 16. Equals 0. And now you have to figure out how to handle this. Okay, we have to factor that. X to the 4th minus 16. Like I said, all these problems today are very set up. They're set up to work nicely, to factor. So x to the 4th minus 16 is just x squared plus 4, x squared minus 4. check it if you want, but you can see that I noticed that there's no middle thing here. It's just an x to the fourth and a 16. So I know x squared times x squared will make x to the fourth, and I know 4 times 4 makes 16. And I want the middle to go away because there is nothing else. There's only x to the fourth and the 16. So as long as these are the same, only one is plus and one is minus, look what happens. You get negative 4x squared plus 4x squared. That's 0. That's nothing. This foils out to make this. So far so good. Notice what happened. I have something times something times something equals 0. That means that x equals 0, x squared plus 4 equals 0, and x squared minus 4 equals 0. So there's one answer right there, just x equals 0. You could even just look at the common sense that one of the answers must be 0 to this problem, because if I took this 0, put it in here, I'd get 0 to the 5th, which is 0, minus 16 times 0, which is 0. So 0 minus 0, 0. Yep, 0 is an answer. The other ones are kind of similar to what we've been doing here. It's x squared equals negative 4, and then x equals plus or minus square root negative 4, but that's just x equals plus or minus 2i. This one here, x squared equals 4. Now we're going to square root on that one. You get x equals plus or minus square root of 4, but that's not I, that's just plus or minus 2. Fifth power equation. 1, 2, 3, 4, 5 answers. Some of them are imaginary, but we got 3 nice ones on this one. We got plus or minus 2 and 0. 3 regular old numbers. This next one's just another pure formula. We talked about it in the last lesson, and we'll talk about it again. It's something you just have to recognize. This is a sum of 2 cubes. This is x cubed plus 1 cubed. And there's a special formula to factor that. It's pretty much just a pure formula. So let's write it out first. It's going to be x cubed plus 1 cubed equals 0. Just so you can see that this is a cubed, this is a cubed plus b cubed. The formula is a cubed plus b cubed equals, now this is the formula part. It's going to be a plus b, and then a squared minus ab plus b squared. I showed you yesterday if it's minus here instead of plus, if this was a minus in there, it just change. It's the same formula, but now this would change to a minus, this would change to a plus. This is always plus. But for now, I'm just writing the one down that relates to exactly what we're doing right now. So for this problem, that means it equals x plus 1, because a is x, that's a, and b is 1. So a plus b is x plus 1. Then we have x squared minus, and then we have, it's going to be 1 times x, or x times 1, because the a and the b are x and 1. So we're just going to, 1 times x is x, so we're just going to write x, and then plus b squared. Well, b is 1, don't forget, b is right here. That's your a cubed plus b cubed. This is b, this is a. So b is 1, so 1 times 1 over here for b squared is 1. And that has to equal 0. Don't forget, we have a problem up here. It's this thing equals 0. So that's this equals 0. We're not done. Remember, this is an equation we're trying to solve. So it's going to be now x plus 1 equals 0, and x squared minus x plus 1 equals 0. This is an easy answer here. There's one answer right there. The other one's not so easy. Okay, this one right here, that doesn't factor. Usually when I think pretty much every time you use this formula right here, this is not going to be a pretty factoring problem. But you can always use the quadratic formula. We need the answers. We don't have the answers right now. We only have one of the answers. This is just saying x squared minus x plus 1 equals 0. It doesn't say x equals. We need it to say x equals. So we have to solve this equation. And if it doesn't factor, which it doesn't, then the next best thing is just quadratic formula. So I'm running out of room here, but I'm going to try it. So it's going to be negative 1 plus or minus square root negative 1 squared minus 4 times 1 times 1 all over 2 times 1. Pretty easy because the numbers are so small, they're just a bunch of ones. That equals 1 plus or minus, and by the way, this is x equals. That's what quadratic formula does. It gives you answers. Plus or minus 1 times 1 is 1, minus 4 all over 2. I just continued on a new page for you guys here, so hopefully you just continue with your notes. If you, obviously if you have this written down from the last page, then you can see where all I did on this next step is 1 minus 4 is negative 3. And finally, there's not a whole lot we can do with this. It's not a pretty answer, but it's going to be x equals 1 plus or minus I root 3 over 2. So we have that. That's the best we can do there. It's not a nice answer. That's how our quadratic formula answers usually look. Let's not forget we had another answer. I believe it was x equals negative 1. And this was a third power equation. I think I can go back and show you that while I'm recording. Let me see. Well, I don't think I can switch it back to show you, but you have it. You have it on your notes there. But it was a third power. It was x cubed plus 1. And so it's third power, and we have 3 answers. One answer right here, and then 2 and 3. Those are our separate answers written as one thing, but that's 1, 2, 3 answers. All right, I'm going to do one more. This video is getting a little longer than most, but I think the more examples you see, the better. So here we go. One more problem. It's fairly repetitive with what I did earlier, but it was one of the newer concepts, so I thought you might want to see it one more time. Step 1. Notice that there's an x in everything. Whenever there's common stuff in all parts of the equation, then we're going to want to factor that out, GCF. So the first thing we're going to do is just go x cubed plus 3x squared plus 2x plus 6 equals 0. So right there, I mean, just by doing that little thing of pulling out this x that was in all of them, we have an answer already. We know that no matter what happens here, we have x equals 0. But this also needs to factor as well, and so we'll save this x equals 0 till later. This problem is going to be similar to what we did earlier. This is 4 terms. 1, 2, 3, 4. Whenever you have 4 terms, you need to think about it. It's really the only way to factor with 4 terms is to think of it like 2 and 2. We call this factor by grouping. I'm going to do a little faster this time though. Okay, so we're going to just let the x hang out. And then this the first underlined red thing has an x squared common. So actually I'm going to put like a bracket right here and just let that x hang out on to the left there. This x, just let that sit there. Don't even worry about it. We're just focusing on just this thing. Okay. So there's an x squared that's the GCF of these two things. There's an x squared in both of those. So that's my GCF. And I'm left with parentheses x plus 3. The other one has a GCF of 2. There's a 2 in both of these. So I'm going to put a 2 out front, and I'm left with, once again, x plus 3. Like I said earlier, these problems are completely rigged. If you do the factor by grouping correctly, there's always a common thing in each of these, x plus 3 in this case. So now we're going to factor, we're going to leave the x here. We're going to go ahead and leave the bracket just for now. And we're going to factor out the common x plus 3. And we're left with x squared plus 2. This is in both. It came out front as a GCF. And I'm left with this thing plus this. This would distribute to there to make this, and this would distribute to there to make this. It's a weird kind of GCF, but it is a GCF. It's just a GCF that's in parentheses instead of just being one number. All right, now these brackets are kind of a waste. What we really have now is we just have this thing times this thing times this thing equals 0. So we set them all individually equal to 0. Like so. This is an answer already. This is x equals -3. So there's that answer right there. And then this one we got to do a little bit of work. We get x squared equals -2. X equals plus or minus square root -2, which means x equals plus or minus I square root 2. Fourth power equation, the degree, the highest power, the degree of that equation is 4. 1 answer, 2 answers, 3 answers, 4 answers. 1, 2, 3, 4. I don't think you'll find too many surprises on the homework if you watch this video and took careful notes on them. I think I pulled a lot of these problems from the homework. I tried to mix it up a little bit so you'd have different things to look at. You can do it. Work hard, be nice, see you soon.